In our notes today, we're going to be talking about solving a literal equation, which is an equation with more than one variable. So not just an x, but maybe an x, y, and a z. We often call those formulas. It's probably what you're more comfortable with, which is an equation that relates two or more quantities so that they really have a meaning. So formulas have meanings. For example, area, which is length times width, so A equals LW, or the Pythagorean theorem, A squared plus B squared equals C squared. So they're equations with more than one variable involved in them. So occasionally we want to solve these literal equations or formulas for a different variable. So rather than solving for the A in area, we might want to solve for the length and figure out what it is in terms of A and W. To do that, we're going to move all terms with that variable to one side of the equation, if necessary, if it's not already there. Secondly, we're going to move all the other terms to the other side of the equation. And then finally, once we do that, we're going to try and isolate the variable. All right, so let's take a look at example 1a. All right, in this, we are solving for all of these, we're solving for A. So we want all of them to be terms of A, so we want it to say A equals stuff when we finish up. So we want to locate where the, let's see if I can do this here. We want to locate where the A is in this equation, so you can see it right here. Here's my A right there. And it's only on one side. So step one, we've got all the terms that have an A in it on the left side of the equation. So two, we want to move all the terms without that variable to the other side. So the only term without that variable is the x. So I am going to add the x to both sides. So when I do that, I'm going to end up with 1/4 AB squared. That's going to subtract out, and I'm going to be left with a C plus X on that right side. So step 3, we want to isolate by multiplying or dividing, factoring if necessary. So on this one, we're going to need to get rid of the 1/4 right there. So to do that, to get rid of the 1/4, we're going to multiply both sides by the reciprocal. So I'll multiply both sides of this equation by 4 and be left with 4 times 1/4 is 1. So I'm going to have A B squared is equal to, and I'll distribute. So that's going to give me 4C plus 4X. Lastly, I need to remove the B squared. And since the B squared is multiplied onto this A, if there's no sign in the middle, that means it's multiplied. To undo multiplication, I'm going to divide it. So I want to divide both sides by the B squared. And that will leave us with, let's see here, that's going to leave us with, on the left side, these are going to divide out. A is equal to 4C plus 4X divided by B to the second power. And that's my answer. It's solved for A. Example B, again, I'm going to be solving for A, so I want to spot where they are. So here's an A right here, and here's an A right here. So I want to get the A's to the same side. So I'm going to move my smaller A, so I'm going to add A to both sides. So we'll do that. And now we'll be left with 3A minus 3B plus C equals D, and then they'll subtract out. Next, I want to get all my terms without an A to the other side, so I'm going to undo them opposite. So it's going to be plus 3B on both sides and minus C on both sides. And that will yield, let's see, we have 3A, those subtract out, is equal to D plus 3B minus C. And finally, to finish isolating a, since 3 is multiplied times a, to undo it, I'm going to divide both sides by 3. And I'm going to be left with, oops, that cancels, that totally canceled, didn't it? Let's see, what did I have here? 3a. 3a. So I'm going to divide both sides by 3. And that's going to leave me with a is equal to d plus 3b minus c over 3. Example C, again, we're solving for a, so I'm going to focus on where those a's are. So here's an a here. Well, that's the only one. So my a is on one side. My other terms are on the other side. So notice that left side's only one term. That fraction's just a single term with an a in it. And the other terms are non-a terms. So we want to start undoing. So the first thing I'm going to undo is the multiplication. So this plus 5 up here, if I'm doing a reverse PEMDAS going backwards, this is actually kind of grouped right there together. So I cannot undo the 5 quite yet. So the first thing I'm going to do is to undo the 4. So I have a fraction bar 4, which means it's divided by 4. So to undo it, I am going to multiply both sides by 4. So multiply both sides by 4. Then I'll be left, these cancel. So I'll be left with a plus 5 is equal to distribute 4c plus 8b. Now it's important to know you cannot subtract that 5 up there first. It is grouped, and going a reverse PEMDAS, I would do any addition and subtraction first, going backwards. Then I'd go back to the multiplication and division. And lastly, I'm going to get to the exponents and finally the parentheses. So that parentheses up there is done last. So once I get here, to finish undoing it, I am going to get rid of the 5. So to undo it, subtract 5 from both sides. And I will be left with, here, that goes away, a is equal to 4c plus 8b minus 5. And that's my final answer. Part D, I have my a right here. Again, just one term on the left, one term on the right. So you can't move anything with the addition and subtraction here. So the first thing I'm going to undo is that 3/5 that's multiplied in front. So to undo it, I will multiply both sides by the reciprocal. So I'm going to multiply both sides by 5/3. So times 5/3. This will undo, and I'll be left with a plus 2 is equal to 5/3. Okay. And finally, to finish isolating the a, I'm going to subtract 2 from both sides. And that's going to leave me with, this goes away, a is equal to 5/3. Okay, subtract 2. And we're going to do one more here. Example 2 is it's a little bit of a twist here on this. All right, so first thing I have is I have an x. Oh, this time notice that I am solving for x. So I'm going to notice where my x terms are, which are here and here. And I want to get my x terms on one side and my y terms on the other. So I think what I'm going to do, you can't tell which one's bigger, can you, because one's an a and one's a 3, is that I am going to subtract the ax from both sides. And that's going to leave me with, if those go away, that leaves me with by is equal to 3x minus ax. So now I need to isolate my x, and but there's one here, one here. I can't add those two terms together from looking at that. So what I'm going to do to help me see what's going to happen is I am going to divide, but I'm going to divide by factoring out that GCF of an x. So that's going to leave me with 3 minus a. and I'm going to factor out the x over here is equal to by. So this time I didn't do something to both sides. What I did is just readjusted the looks of that right side so that it's essentially added. I went from the two terms down to one term right there. So I have this. So I want to isolate my x. So I'm going to divide both sides by its coefficient, which is 3 minus a on both sides. So I'm going to do this. These will cancel. They're identical, so they're going to cancel. Clever one. And that's going to leave me with by over 3 minus a is equal to x. We're going to hold these next two examples for tomorrow in class, and we'll work on those. That'll be the step up harder. But what I want you to do right now is I want you to go to the next page, and I would like for you to work, I believe, A. So I want you to do A and not B, but let's do C, and we'll do the other two in class tomorrow. So give a try right now at A, C. Turn off the computer, turn off your, just stop and pause, and come back and check your answer and see how you did when you did it. You can kind of compare. First, notice that I'm solving for y this time. So I'm going to subtract ax from both sides to get the y isolated. So I have by is equal to c minus ax. The last thing I'll do is to divide both sides by b to isolate the y, and it leaves me with y equals the quantity c minus ax over b. Now try C. This time I'm solving for x, so I've pointed out where those x's are. They're on two opposite sides of the equal, so the first thing to do, put them together. So plus 3x on both sides. I decided to be plus 3x rather than subtracting the ax because I wanted my x's to be positive. So I'm going to go that route. And so you can see what I get, 5y equals the ax plus 3x plus 4. Next, I needed again to get the terms that did not have an x in it to the other side. So I subtracted 4 from both sides. So I have 5y minus 4 is equal to ax plus 3x. I factored out the x so that I had just a single x on that right side, and I'm going to end by dividing both sides by the a plus 3. And here's that answer. 5y minus 4 divided by a plus 3 is equal to x. Note any questions that you had as you work through this video. Make a note in your notes so that you can ask that question tomorrow because somebody else may have had the same question. See you next class.